And it goes a little something like.
Good day, everyone. So before we start our discussion, first let's have a motivation. And this motivation is called cabbage relay. So I have here a handcrafted cabbage. Each part of the paper has a question in it. When the music is played, you will pass this cabbage to your seatmate. When the music stops, the student with the cabbage will get a piece of it and answer the given questions. This process repeats until there is none left. So since we are in the virtual, so we cannot do this, but you can actually answer so since we are in the virtual, so good day everyone. So before we start our discussion, first let's have a motivation. And this motivation is called cabbage relay. So if when we are in the face-to-face settings, the we will do so when we are in the face-to-face settings, we will do that. But since this is virtual, we just or you just have to answer these questions in the comment section. So the first question is, in a scale of 1 to 10, 1 is being the lowest and 10 being the highest, how well versed are you in performing the fundamental operations in measurements? Question number 2. How does measurement help you solve problems in everyday life? And lastly, the third question is, how effective are you as an inspiring teacher at providing instructional strategies? So don't forget to answer that questions in the comment section because this bec- so don't forget to answer that questions in the comment section because since we are in the so don't forget to answer that questions. So don't forget to answer that questions in the comment section below. So good morning everyone. Today we will discuss about the chapter 9, which is the measurements. By the way, I'm Christine Dasri Abia Alleluia, and I am going to discuss the elapsed time. So what is elapsed time? Elapsed time, it is the actual time taken from the starting time up to the ending time. So meaning, elapsed time is taken from the start time until the end time. So for example, let's say the start time here is 9 a.m. and then the end time is 9:30 a.m. So we just have to put the time that is been taken between the start time and the end time, which is the 10 minutes, and then we add 10 minutes, and then we add lastly at 10 minutes in order to get to the end time, which is 9:30 a.m. So 9:30, so 10 minutes plus 10 minutes plus 10 minutes is equals to 30 minutes. That's why the elapsed time of start so in this so in this so in this so in this example the elapsed time is 30 minutes. So now let's move on in identifying a digital. So now let's move on in identifying the digital. So now let's move on in identifying what is the parts of now let's move on in identifying the parts of a digital clock as well as analog clock. But first, let's unlock what is the parts of digital clock. So digital clock is look like this. So the 9 here represents us hours, and the 35 here represents us minutes. And then the 19, if we put 19 over here, because some digital clocks have a seconds, so we put seconds here not for you not to be confused. So the 19 here is seconds. And AM represents as meridium. Meridium. So AM here represents meridium. So AM means from midnight until morning before noon. And then PM represents as afternoon before midnight. So, so here I have a, so here I want you to look at, so here I have here the equivalence of 1 hour is equal to 60 minutes and 1 minute is equals to 60 seconds. So I show here because this is very important or this is useful for us in the so here I put 1 hour is equals to 60 minutes and 1 minute is equals to 60 seconds. So I put here the equivalent of 60 minutes as well as the 1 minute because this is very useful to us, especially when we are using different kinds of methods later on. So now let's identify the parts of a analog clock. So analog clock is look like this. So the blue arrow here represent as an hour hand. The blue arrow here represent as our hand, and the red arrow in the analog clock represents as minute hand, and the little line over here beside the numbers is called a minute. So since we are done tackling about the parts of a digital clock and analog clock, now let's have an example or some of the methods and strategies for you to look for the elapsed time on it and easily and more easily and for you to this is an easy method and for you to remember it. Uh, this is an easiest method. Now I will show you. To you the different methods and strategies and how to solve elapsed time for you to easily to remember and easily for you to understand how to solve for elapsed time. So the problem, the story problem goes this way. Auntie helps. So the story problem goes this way. Andy helps her mother in cleaning their house. They started cleaning at 7:32 a.m. and finished at 8:25 a.m. So the method 1 is to use number line. So number line looks like this. So all we have to do is to draw like this and put some numbers. So number line looks like this. So the first one we have so the so the number line looks like this. So all we have to do is to after doing the number line is all we have to do is to identify the start time. So the start time here is 7:32 a.m. So since this is 7:30, then 7:31, and then 7:32. And then after looking for the start time, let's move on in looking for the end time. So 8:25 a.m. is the end time. This this is look like this. And then after doing that, all we have to do is to add these minutes from 7:32 until the end time, which is 8:25. So 8 minutes, so 3 minutes plus 5 minutes plus 5 minutes. So since So all we have to do is to add these minutes. So all we have to do is to add these minutes from 3 all we have to do is to add these minutes from 7:32 until the end time, which is 8:25 a.m. So now all we have to do is to add like this. So we have 3 minutes. All we have to do is to count it. 1, 2, 3. So we have 3 minutes, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minutes plus 10 minutes plus 10 minutes plus 10 minutes. So 3 minutes plus 10 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 minutes is equals to 53 minutes. So all in all, the elapsed time that Andy helps her mother in cleaning her house is 53 minutes. So another method that I will teach to you guys is method number 2, which is subtraction. So this is the formula. So elapsed time equals end time minus start time. So again, let's identify what is the end time here and to substitute or add in place. So the end time here is 8:25 a.m. So 8:25 a.m. minus the start time, which is 7:32 a.m. is equals to and minus the start time, which is 7:32 a.m. So since since the denominator is bigger than numerator, all we have to do is to borrow an r from 8. So when we borrow 1 r to 8, it will become 7. And 1 hour is equals to 60 minutes. All we have to do is to add 60 minutes. This is the equivalent for 1 hour that we borrow from 8 plus 25 minutes. So all in all, we have 85 minutes. So now we can subtract because the numerator is bigger now. So 85 minus 32 is equals to 53, and 7 minus 7 is equals to 0. So that so all in all, the elapsed time is still 53 minutes. So even though we use different methods, still we got the same answer. So it's up to you guys if well it's up to you guys if you are comfortable in solving in number line or in subtraction. So it's up to you what you will be going to use in finding the elapsed time. It's up to you on what method you are going to use in finding the elapsed time. So therefore, they cleaned the house for exact 53 minutes. So that is the answer of our problem. So now I want you to try, and if you understand how to solve last time. So now I want you to try solving how to find elapsed time. So since this is virtual, all you have to do is to get your scratch paper or try to answer if you got the correct answer. So you should also you get your sketch paper and then try to solve if you got the correct answer. So now let's start the first one. So the story goes this way. During weekends, Allison helped her mother. During weekends, Allison helps her mother in washing their clothes. They started washing at 4:28 p.m. and finished at 5:09 p.m. How long did they wash their clothes? So during weekends, Allison helps her mother in washing their clothes. They started washing at 4:25 p.m. and they started washing at 4:28 p.m. and finished at 5:09 p.m. How long did they wash their clothes? So another one is Chris is working as a part-time tutor every day. He Chris is and now and another problem is Chris is working as a part-time tutor every day. He starts at 10 in the morning and ends at 1 in the afternoon without breaks. How long does he work as a tutor? How long does he work as a tutor per day? So now let's unlock the problems. So now let's try to solve or to find the elapsed time of those problems. So the first problem So the first problem. So all we have to do is to so the first problem, all we have to do is to find the elapsed time using subtraction, the method number 2. So all we have to do is to find the elapsed time, and all we have to do is to find the end time. The end time here is 5:09 p.m. 5:09 p.m. and the start time here is 4:28 p.m. So method number 2, all we have to do is to subtract it. So since the denominator is bigger than numerator, all we have to do is to borrow an r from 5. So again, 1 hour is equals to 60 minutes. So since we get 1 hour from 5, so this will become 4. And then 60 plus 9 is equals to 69. So now we can subtract it because the numerator is now bigger. So 69 minus 28, it will give us 41. Why? Because 9 minus 8 is equals to 1. Then 6 minus 2 is equals to 4. And then 4 minus 4 is equals to 0. So all in all, they wash their clothes. Therefore, they wash their clothes for exactly 41 minutes. And now, let's move on to another. Now, let's move on to the other problem. So, this problem, we will use the first method, which is the number line. So, all we have to do is to draw a line like this, a number line, and then after doing that, we will identify the start time. So the start time here is 10 a.m. and the end time here is 1 p.m. So all we have to do is next is to find or to look the so here all we have so next all we have to do is to find the so now all we have to do is to find the hours or minutes between the start time and the end time. So let's put here 11 a.m. or 1 hour and then 12 noon, which is 1 hour also, and then 12 noon to 1 p.m. it will also give us 1 hour. So all in all, 1 hour plus 1 hour plus 1 hour, it will give us 3 hours. So the elapsed time here, therefore he worked for 3 hours every day as a part-time tutor. So so if when we are in the face-to-face settings, I will give you these worksheets for you to work on and for me to know if you really understand the topic, as well as for me to identify if I can give a help if you are struggling with this kind of lessons, and for me to help you to understand and to help you and for you to help you where you are struggling. So if when we are in the face-to-face settings, I will give you these worksheets because this is a way to test your knowledge if you really understood the topic, as well as this is also my way to identify if I can give a helping hand. If this is also a way to give you a helping hand to really understand this kind of lesson, because as a future educator, it is very important to know the basic, as well as the as because as a future educator, it is very important that we should know these lessons, because how can we teach if we don't know how to solve for it, and how can we give knowledge if we ourselves are not knowledgeable in this lesson? So as a future educator, we should always be knowledgeable in all. So, as a future educator, we should always have a kind of so as a future educator, it is very important for us to know this. So, I think that would be all for my part. So, thank you so much for listening and have a great day.
Good day everyone, I am Nicole Andrea Navarro, and in this video I will be going to discuss about Lesson 2 and Lesson 3 in Chapter 9 Measurements. Since Lesson 1 has been already discussed, so now let's proceed to Lesson 2. So Lesson 2 is all about speed, distance, and time. So in this lesson, we'll be going to know the meaning of distance, time, and speed, and how are we going to solve or calculate the speed, distance, and time. So now so most of us, if not all, travel to and from school every day. It means that we already have at least an estimate of the distance between our house and school and the length of time it takes to travel. So distance, speed or rate, and time are three important concepts in mathematics which we usually encounter as word problems, right? So now let's proceed to distance. So when we say distance, it is the length measured between 2 points or the length of space traveled by a moving object. So when we say distance, this is what we means that you are going to calculate from the reference point or your starting point to the destination where you are going to go. So the most common unit being used to measure distance is kilometer or meters. So let us all remember that in terms of distance, the unit we are going to use is kilometer or meters. So is that understood? So now let's proceed to time. Time is the measured or measurable period during which a condition, process, or action exists or takes place. It is usually expressed in hours or minutes. So in terms of time, it is usually expressed as hours or minutes, or how many hours or minutes that we traveled. So that's for time. So now let's proceed with speed. So when we say speed, it is the speed at which an object or person travels. So we usually say the bus runs 60 km per hour. So take note that kph is the symbol for kilometers per hour. So this triangle is simply describes to us on how we are going to easily remember the equation or the formula in getting distance, speed, and time. So let's go with distance. So distance is equals to speed times time. So in getting the distance, we must multiply the speed and time. So for speed is equals to distance over time. So in speed, we are going to divide the distance and time. And in time is equals to distance over speed. So is that understood? Alright. In order to clearly understand or to know how we are going to get the distance, speed, and time, I have prepared here an examples. So let's go with the examples. So now let's have for example in distance. So the problem is Ike drives his car at a constant speed of 75 km per hour. How far will be from his starting point after 3.5 hours? So we all know that distance is equals to speed times time. So the speed in this problem is 75 km per hour. And the time is 3.5 hours. So what we are going to do now is to multiply 75 times 3.5. So, 75 times 3.5 is equals to 262.5 kilometers. Since we are finding the distance of this problem, therefore we will use kilometers since the unit for distance is kilometer. So another way on getting this answer of this example or getting a distance is this. We will table the every kilometer that we in this problem. So we have here 75 kilometer in 1 hour, 75 kilometer again in 1 hour, 75 kilometer in 1 hour, and 75 divided by 2 kilometer over is equals to 0.5 hour. So now what we are going to do is to add all the kilometers. So we have here distance is equals to 75 plus 75 plus 75 plus 75 over 2. So is equals to 75 plus 75 plus 75 plus 37.5 is equals to 262 kilometer. So as you can see, we have the same answer in this method and in this method. So we can use many ways in getting distance. For this is just an example how we're going to get distance. So is that understood? Very good. So now let's move on, for example, in time. So now let's have an examples on how to get the time. So the problem here is rain travels at a speed of 60 km per hour. At the same rate, how long will it take him to cover a 240 km distance? So the given facts here is the speed is equals to 60 km per hour and the distance is 240 kilometers. So again, how are we going to get the time? Yes. So time is equals to distance over speed. So the unknown here is time. So therefore, we are going to divide speed and the distance. So here it is. Time is equals to speed over distance is equals to the speed here is 60 km per hour over 240 kilometers. So 60 divided by 242 is equals to 4. Therefore, it takes 4 hours to get him into his destination. So it is easily to solve time because what we are going to do is just to divide the speed and the distance of the problem. So is that clear? Very good. So now for last is the speed. Let's have an example on how we are going to solve or find the speed. And now let's have for the speed. So the example here, so we have here the example of speed. So the problem is Mr. Argy Palomo left his apartment at 10:30 a.m. and arrived in Dumaguete City with 245 km away at 2 p.m. What was his speed in kilometers per hour? So in this solution, in this situation, we have to record the time arrival and the time departure. So the time arrival is 2 p.m. and the time of departure is 10:30 a.m. So the distance is 245. And what we are going to find here is what is the unknown is the speed. So first is find out the time by subtracting time of departure from time of arrival. So here is the table so that we can easily find what is the time departure and what is the time arrival of this problem. So we have here, so therefore the time arrived and time departed is 3 hours and 30 minutes. So by recording the time arrival and time departed, we easily find how many hours did Mr. Paloma talk to reach Dumaguete City. So it took him 3 hours and 30 minutes. So now we will going to solve the speed, since speed is divided but is equals to distance over time. So the distance here is 245 divided by 3.5. Therefore, it 70 kilometers per hour. So he has 70 kilometers per hour speed. So that's the way on how are we going to compute the speed. So a good activity for this to our pupils is the speed activity challenge. So this challenge is great on teaching our students and to have a collaboration also to their peers. So that's all for lesson 2. So now let's proceed to lesson 3. Since lesson 2 is already discussed, now let's move on to lesson 3. So lesson 3 is all about perimeter. So what is perimeter? So when we say perimeter, it is the distance around a figure. It is computed by adding the length sides of a polygon. In general, the formula for perimeter is equals to perimeter, or P, is equals to side 1 plus side 2 plus side 3 and so on and so forth. So, for example, this triangle. So this triangle has this 14 mm here, 18 mm in the other side, and in bottom has 6 mm. So what we are going to do with this triangle to get the perimeter of this triangle is to add the sides. So we have here side 1 is equals to 14, side 2 is 18, and side 3 is 6 mm. So 14 plus 18 plus 6 is equals to 38 mm. So that's how we are going to find the perimeter of a figure or a shape or polygons. So another example is here. We have an example. So first is this figure. So what is this figure? Yes, it is a triangle. This triangle has 16 centimeters. So the figure is an equilateral triangle. It means that its 3 sides are congruent. So aside from adding repeatedly the 3 lengths, perimeter is equals to 18 plus 18 plus 18, we may instead multiply it by 3. So it is equals to P is equals to 3S, means 3 sides, or 3 times 18. 18 comes from here, since the size of this triangle is 18 centimeters. So we will going to multiply 3 times 18 is equals to 54. The same answer with adding 18 plus 18 plus 18 is equals to 54 centimeters. So another example is this figure. So what is this figure? Yes, this is a square. So a square has 4 sides, right? It is congruent sides. So instead of adding since this square has 35 dm, 35 plus 35 plus 35 plus 35, obviously it's much easier to simply multiply the sides by 4. So we have 4s. So we will go into 4. Then the size of this square is 35. We will multiply 4. So 4 times 35 is equals to 140. So the answer is 140 dm. So that's how we are going to find the perimeter of this shape polygon. So let's move on to example number 3. So this is a triangle. So this triangle has 15 centimeter here and 6.5 centimeter here. So a rectangle has two pairs of opposite sides, yes, that are parallel and congruent. So this is perimeter is equals 15.2 plus 15.2 plus 6.5 plus 6.5. Since two pairs of sides are congruent, then we can solve it this way. So another way on how we are going to solve this triangle is equals to perimeter is equals to length plus to width. So equals 2 times 15.2 plus 2 times 6.5 is equals to, we will multiply first the 2 times 15.2 is equals to 30 and 2.6.5 is equals to 13. So 30.4 plus 13 is equals to 43.4 centimeter. Therefore, the perimeter of this rectangle is 43.4 centimeter. And the last example is this polygon. So the figure is a regular pentagon. Pentagon has 5 sides, right? 1, 2, 3, 4, and 5. If one side measures 73 and 1/2 mm, the perimeter is equals to P is equals to 73 and 1/2 plus 73 and 1/2 plus 73 and 1/2 plus 73 and 1/2 plus 73 and 1/2. It's so long, right? So instead of doing that, we can use this another way. So 73 and 1/2 times 5. So where did we get the 5? 5 because this figure has 5 sides, which is equals to 73 and 1/2. Therefore, we will multiply 73 and 1/2 into 5. And the answer is 367 and 1/2 mm. So by doing this way, it's so easy and it's not long for us to write the formula. So that's all for perimeter. The activity that is very applicable for our students to give in this lesson is this. By giving them these figures, we will group them into 5, and with that, they will have a collaboration on how they are going to find the perimeter of each this shape. And also we can give them a problem solving with solutions. So that's all for lesson 3. Thank you.
Good morning, everyone. This time, we're going to talk about the lesson 4, circumference. And we were going to tackle about on how to find the circumference of a circle. And then, we are going to use a strategy in order for us to easily understand our topic, which is circumference. So, are you ready, class? Alright, very good. So now, let us know what circumference is. Circumference, it refers to the distance around the circle. So it means that if we are going to open this circle into a straight line, the length of it is the circumference. So this here is our circumference. So now, as we go along, with our discussion, we need to know the terms of identifying the circumference of a circle. So first is the pi. It can be read as pi, as in pi that used to like snacks like that. So pi is the ratio of circumference of a circle to its diameter. The rational numbers is 3.14 in decimal or 22/7 in fractions. And the next one is the diameter. The symbol of diameter is just letter D. It is a chord that connects 2 points on the circle and passes through the center of the circle. And the radius, the symbol of radius is R. It is a line segment from the center of the circle to any point of the circle. So it is the 1/2. It is the 1/2 of the diameter. Like for example, this one. Like for example, this one. This is the diameter, as you can see in the pink one. This is the diameter, and this one is the radius. Because the diameter, it is the half of the circle, and the radius is the half of the yes, very good. It is the half of the diameter. Very good. So in order to find the circumference, we have here the formula. Formulas in finding the circumference of the circle. Like for example, circumference is equals to pi multiplied by the diameter. So we all know that the pi is equivalent to 3.14, right? Right, class? Very good. So the formula is circumference is equals to pi multiplied by the diameter if the diameter is given. Right? Are we clear? Very good. So the next one is the circumference is equals to 2 multiplied by the pi multiplied by radius. So we are going to use this formula if the radius is given. Are we clear, people at the back? Alright, very good. So we have also here the formula in finding the diameter of a circle from the circumference. So as we find the diameter of the circumference, we must know the circumference of the circle. So if we're going to find the diameter, let's just find first the circumference. So that in order to find the diameter of the circumference of the circle, the formula that we are going to use is diameter is equals to circumference divided by the pi. So class, what is the equivalent of pi? Yes, Fiona? Very good. It is 3.14. So what is the symbol of diameter? Yes, Micah? Very good. It is letter D. So now, what is the symbol of radius? Yes, Harry? Alright, very good. It is R. So now, I have here an example for you to really understand our lesson for today. So first example, we have here a diameter of 20 centimeter. So as you can see, the diameter is given. So what formula are we going to use? Yes, very good. This one. The formula that we are going to use is the circumference is equals to pi times diameter. So here, we are going to substitute the equivalent of pi, which is 3.14 multiplied by the 20 centimeter. Our what? Yes, our diameter. So as we multiply the two factors, we come up with a product of 62.80 centimeter. So class, as we multiply these two, the form that we are going to use is this one. We have here two factors. 3.14 multiplied by 20 centimeter. So, this one here are the, what is this? Yes, multiplicand. And this one under the multiplicand is our multiplier. And this is our, yes, we are going to multiply these two factors. Very good. So the first one the first step to multiply this one is the 0. 4 times 0 is equal to 0. And then this one here, the multiplier that we are using is the 2. So 4 times 2 is equals to 8. And 1 times 2 is equals to 2. 3 times 2 is equals to 6. Then after we multiply these two, we add the answer of these two factors. That is why we come up with a product of 62.80. Alright. So, for example number 2, we have here a given radius of 8 decimeter. So, what formula we are going to use? Yes, Fiona? Yes, very good. This one. Circumference is equals to 2 times the pi times the radius. So, we are just going to substitute all the given numbers. 2 times 3.14 times 8 decimeter. And first, we are going to multiply these two. 2 times 3.14. That is why we come up with a product of 6.28. Then we copy the 8 decimeter here. So that the two of them will be multiplied. So 6.28 times 8 decimeter is equals to 50.24 decimeter. Just like what we did in example number 1, we use the factor and the product. We just multiply the multiplicand and the multiplier and then add. So that is why we come up with a product of this one. So for the third example is, what is the circumference of a circular garden with a diameter of 5.2 meters? Alright. So for this one, Harry, what do you think the formula we are going to use? Alright, very good. It's the diameter. Circumference is equals to pi times the diameter. So, in here, same for the process of number 1. We use the formula and then we substitute, and then after we multiply these two factors, we have here the product, which is 16.328 meters. So class, are we clear? Alright, very good. So now, I have here an activity for you to have fun and to, yes, very good, to understand our lesson for today. So, the title of our game or activity is What's My Circumference? So, are you ready? All right, very good. So, for the instruction, please listen. I need you to form 6 groups, and each group will be given 3 paper plates. Do you know what paper plates is? All right, very good. So, the paper plate contains a problem requiring finding the circumference of a circle with a specific diameter or radius, meaning the paper plate has a given radius or diameter. And then you are given one long bond paper on which to write your solution. So you need to give your solution. I need to see your solution. Are we clear, class? All right, very good. So the group that completes the task first will earn a well-deserved prize, while others will receive a consolation prize for their efforts. So, you need to answer faster and correctly, right? It's because if you win this activity, you are given a prize. So, are we clear? All right, very good. Okay, now form 6 groups. So 1, 2, 3, and 1, 2, 3. All right, I will give you a paper plates for you too. This one is an example. All right. So as you can see in your paper plates there, it's just like this. So now, I want you to start in 3, 2, 1, start. All right, very good. So now we have here our winner. So what group is the winner? Yes, group number 5. Very good, group number 5. So group number 5 is our winner. And for those who answer very late and yes, you have a consolation prize for your effort. So, are you clear? Is that okay? All right, very good. So, that's all in our lesson, circumference. And I hope you understand it very well so that you can apply it in our real life situation. So, are we clear? Very good.
Good day everyone, I'm Dillis Applemay, and since we've already discussed the lesson 4, which is circumference, and now let's proceed to lesson 5 entitled area. And since we will discuss about area, who can give me first of what area means? Okay? Very good. When we talk about area, it is defined as the total space taken up by flat two-dimensional surface or shape of an object. Okay, so I have here different kinds of shapes, and let's identify each of them. So what do you think are the names of the first and the second shapes? Very good. This is what we call rectangle and a triangle. Now, how about in the third, fourth, fifth shapes? What do you think are the names of these shapes? Very good. In the third shape is what we called parallelogram, while on that fourth shape is what we called trapezoid. Lastly, in the fifth shape is what we called circle. So this shapes class is what we call two-dimensional shapes. So in this lesson, we will find the areas of rectangle, triangle, parallelogram, trapezoid, and a circle. In order for it to be guided, this is how we find the area of a rectangle. Area of a rectangle equals length times width, or we can simply write as LW. Okay, so what is the length of a rectangle? Very good. The length of a rectangle is 5. How about its width? Very good. The width of a rectangle is 3. So we rewrite it as follows. Now, if we multiply the length of a rectangle, which is 5, to its width, which is 3, what would be the answer? Very good. The answer will be 15 square units. So this is the area of a rectangle. However, if we find the area of a square, this is how we do it, class. Area of a square equals side times side, or we can simply write as S squared. Now, this is how we do it, class. Since there is 4 sides of a square, all you need to do is to multiply it by itself. Since our formula here is side times side, and we write as 4 squared. 4 squared. Now, if we multiply 4 times 4, what would be the answer? Very good. So the area of a square is 16 square units. This time, we will now learn how to find the area of triangles, parallelograms, trapezoids, and circles. Remember that the general formula for area is base times height. Let's first discuss the area of a parallelogram. So, since a parallelogram is like a slanting rectangle, then the formula in finding its area is also similar. That is base times height. So take a look how a parallelogram can transform into a rectangle. Now, have you seen how it transforms just by looking at this figure? Very good. Therefore, in finding the area of a parallelogram is base times height, or we can simply write as BH. Now, let's proceed to area of triangles. So take a look of these figures. Each one of them is what we call triangles. Now, if we put another triangles of each sides, this is how it looks like. Okay, so for triangle 1 and 2, it's very obvious that the triangles is half of that parallelogram with the same base and height. And for triangle 3, let's have another way of showing it. Now, for triangle 3, each of these figures is simply two triangles, 3 placed by side to form a parallelogram. Again, it clearly shows that the area of a triangle is half of that parallelogram with the same base and height. Therefore, in finding the area of a triangle is 1/2 times base times height, or we simply write as 1/2 times base times height, or 1/2 times BH. Okay, let's move on to area of trapezoids. And since a trapezoid is also like a rectangle, just like this, now, do you see how they both transform into a rectangle? Very good. Therefore, in finding the area of a trapezoid is 1/2 times base sub 1 plus base sub 2 times height, or we can simply write as 1/2 times b sub 1 plus b sub 2 times h. We will now move to find the area of a circle using a parallelogram. So how the formula of a circle, which is pi r squared, relates with the area of a parallelogram and rectangle, which is base times height. Now, it's for us to find out. So the first step is use a compass to draw a circle and cut it out. And the second step is find the circle 3 times as shown to get equal wedges. And the third step is unfold and shade 1/2 of the circle. And the last step is cut out the wedges and fit the pieces together to form a figure that looks like a parallelogram. So we all know that to find the area of a parallelogram is base times height. Now, to find the area of a circle, substitute pi r for base and r for height. So now, we simply write as pi r squared. Hence, to find the area of a circle is pi r squared. Alright, since we've already discussed the lesson 5, which is area, now let's proceed to lesson 6 entitled surface area. Now, I have a question. Do you have any idea of what surface area is? Very good. Surface area of a solid object is a measure of the total area that the surface of the objects occupies. Now, another way to make the study of surface area more concrete is to visualize or draw the net of the solid figures. So I have here pictures. And let me check if you know these objects. So what do you think are the names of the first and second pictures? Very good. It is what we call cube and a rectangular prism. Now what about in the third and fourth pictures? Very good. In the third picture is what we call square pyramid. And the fourth picture is what we call cylinder. Now, what do you think are the names of these objects? So this is what we call cone. Lastly, this is what we call sphere. And these objects is what we call net of solid figures. So what are these net of solid figures? So these are used to describe what a 3D shape would like if it was opened out and laid flat. A net is what a 3D shape would look like if it was unfolded. This is how it looks like if these objects are unfolded. So this is 4 cube, rectangular prism, and a square pyramid, cone, cylinder, and a sphere. Now, let us find the surface area of a cube. So it is easy to visualize the surface area of a cube since we already know that it has 6 square faces, which are all congruent. It means that we simply solve the area of one face and multiply the result by 6. And our cube here has 6 centimeter. And if the side or edge of the cube is 4 centimeter, we write it as follows. Now, let us copy 6 here times. Since it is 4 squared, all we need to do is to multiply it by itself. Now, if we multiply 4 times 4, what would be the answer? Very good. The answer will be 16. Finally, we will multiply 6 and 16. Now, 6 times 16 is equal to, very good, 96. Square centimeter. So this is the surface area of a cube. Did you get it, class? Very good. Okay, so let's proceed to find the surface area of a rectangular prism. Now, to find the area of a rectangular prism, we need the measure of the length, width, and height. Okay, so if we take a look at the net of a rectangular prism, we see 3 pairs of faces. Now, to sum up the surface area of a rectangular prism, it is surface area equals front and back faces plus right and left faces plus top and bottom places. Or we can write it as follows. Now, let's copy 2 here. Okay, so what is the length of a rectangular prism? Very good. The length of a rectangular prism is 6. Now, how about the height of a rectangular prism? Very good. The height of a rectangular prism is 4. Now, let's put plus sign here and another open parenthesis and copy 2. So what is the width of a rectangular prism? Very good. A rectangular prism has 3 widths. Now, how about the height of a rectangular prism? Very good. It has 4 height. So the length of a rectangular prism is 6. and its width is 3. Now, let's solve this one. Okay, so 6 times 4 is equal to 24. And if we multiply it by 2, the answer will be 48. Now, how about if we multiply 3 times 4? Very good. The answer will be 12. And if we multiply it by 2, the answer will be 24. Lastly, if we multiply 6 times 3 is equal to 18. And now if we multiply it by 2, the answer will be 36. Now, if we add this, what would be the answer? 48 plus 24 plus 36 is equal to 108. Centimeter squared. So this is the surface area of a rectangular prism. So now let's find the surface area of a square pyramid. Now, to find the surface area of a square pyramid, we only need the measure of the side of the square base and the height of the triangular lateral face. So this is our formula in getting the surface area of a square pyramid. Okay, so now our s squared here is 8 squared. Now, copy the plus sign and 4, and then copy the 1/2. So, our base here is 8. So, let's put it here. And our height of the square pyramid is 12. The first thing we need to do is to cancel out the greatest common factor, which is the 8 and 2. This is the result, which is 8 squared plus 4 times 4 times 12. Now, since we have here 8 squared, all we need to do is to multiply it by itself. Now, if we multiply 8 times 8, the answer will be, very good, the answer will be 64. So, plus, copy 4. Now, if we multiply the base and height, which is 4 and 12, what will be the answer? Very good. The answer will be 48. 48. Okay, so let's copy 64 here. Copy the plus sign. Now, if we multiply 48 times 4, what will be the answer? Very good. The answer will be 192. Now, the last thing we do is to add the remaining numbers, which is 64 and 192. So, 64 plus 192 is equal to, very good, the answer will be 256 millimeter squared. So this is the surface area of a square pyramid. We will now move on in getting the surface area of a cylinder. So this is our formula to find the surface area of a cylinder, which is surface area equals 2 pi r times r plus height. Now, take note that use 22 over 7 for pi. Since the radius is divisible by 7, so computation is easier. So let's write it as follows. Copy 2 times 22 over 7 times our radius here is 14. Okay, so we put 20 here since our height is 20. Now, in order to solve this one, we need to multiply first the 22 over 7 times 14, which is, the answer will be 44. And 44 times 2 is equal to 88. Very good. 88. Now, if we add 14 plus 20, what would be the answer? Very good. So the answer will be 34. Okay, so the last thing we need to do is to multiply 88 and 34. Now, 88 times 34 is equal to, very good, the answer will be 2,992 meters squared. 2,992 meters squared. So this is the surface area of a cylinder. Okay, so now let's proceed to find the surface area of a cone. So this is our formula, which is surface area equals pi r s plus pi r squared. Now, remember that our pi is 22 over 7. But here, we use 3.14 because it's still the same. Now, our radius here is 8. And our slant edge here is 15. And our radius here is 8. The next step we'll do is to multiply 3.14 and 8. Now, 3.14 times 8, what would be the answer? Very good. The answer will be 25.12. Now, if we add these two numbers, which is 15 and 8, what would be the answer? Very good. The answer will be 23. Now, 25.12 times 23 is equal to, very good, the result will be 577.76 millimeters squared. Okay, so this is the surface area of a cone. Lastly, let's now find the surface area of a sphere. So this is our formula in finding the surface area of a sphere, which is surface area equals 4 pi r squared. So let us copy the number 4. So our pi here is 3.14. Now, our radius here is 4.5 decimeter. Now, if we multiply 4 times 3.14, what would be the answer? Very good. The answer will be 12.56. Since it is 4.5 squared, all you need to do is to multiply it by itself. Now, 4.5 times 4.5 is equal to 20.25. So the last thing we need to do is to multiply 12.56 and 20.25. Now, 12.56 times 20.25, what would be the answer? Very good. The answer will be 254.34. 254.34 decimeter squared. Alright, so the surface area of a sphere is 254.34 decimeter squared. Alright, in this lesson, we learned how to find the surface area of three-dimensional shapes, which are cube, rectangular prism, square pyramid, a cylinder, cone, and a sphere. So, that would be all for our lesson for today, and I hope you learned something. And of course, thank you for listening.
Since we're done with lesson 6, let's now proceed to lesson 7, volume.
So what is volume? So volume is the amount of space taken up by a three-dimensional object, and you can measure the volume of solid figures using non-standard or standard units. So standard units are what we usually use to measure things like weight, length, and volume. And on the other hand, using non-standard units is the use of items that isn't a standard metric or customary unit. Now, can you give one item we can use to measure liquid volume with non-standard unit? That's right, we can use cups to measure the space a liquid occupies. And we can find the volume of an object using the water displacement method. So in this method, by dropping the object into a measuring container of water where the volume of the water is known, the object's volume can be calculated by subtracting the volume of the water from the volume of the water and object combined. Now to get the volume of the object, we will be using this formula. So volume of the object is equal to volume water plus object minus volume water. Or we can say volume of the object is equal to the final water level minus the initial water level. Just like for example, the water level is initially at 10 milliliters, and after an irregular object is dropped into the container, the water level raises at 30 milliliters. And what do you think is the volume of the object?
Using the water displacement method, let us find the volume of the object. What is our final water level? That's right, it's 30 milliliters. How about our initial water level? Very good, we have 10 milliliters. Now, 30 minus 10 is equal to 20. That's right. So, using the water displacement method, we get the volume of 20 milliliters. Now, using the water displacement method, let's try to answer this one. Anyone? Okay, that's right, 10 milliliters. How did you get 10 milliliters? That's right, we get 10 milliliters by subtracting our initial water level from our final water level. So what is our final water level? Very good, it's 60. How about our initial water level? That's right, we get 50. So So 60 minus 50 is equal to 10. Very good. So let's not forget our unit, which is milliliters. Okay, so that's it. The volume of our object is 10 milliliters.
Now, what about cubic units? So, when we say cubic unit, in geometry, cubic units can be defined as the units used to measure volume. The volume of a unit cube whose length, width, and height are 1 unit each is 1 cubic unit. Now, each dimension of a unit cube, or the length, width, and height, is 1 unit. So, 1 unit of length with 1 unit of width and 1 unit of height together make a volume of 1 cubic unit.
And now, let's try to find the volume using unit cubes. Now, I have here a rectangular prism filled with unit cubes, and let's count how many cubes make up the layers starting from the bottom layer. So let's count. 1, 2, 3, 4, 5. 1, 2, 3. And 1, 2. So, using the formula length times width times height, we get the total of 30 cubes. Now, why 30? Yes, that's right, because 5 times 3 is equal to 15 times 2 is 30.
Now, to find the volume of a rectangular prism, we need to find the area of the base, which is length times width, and then multiply the area of the base by the height. So, for any prisms, we can use the formula of volume is equal to base times height. But since we are specifically working with the rectangular prisms, we know that our base will be a rectangle. Now, what is the formula for the area of a rectangle again? Correct. So area is equal to length times width. So we can use the formula length times width times height for rectangular prisms. Instead of the base, we can be more specific and put in length times width.
Using the formula length times width times height, find the volume of a rectangular prism with a length of 5 centimeters, a width of 4 centimeters, and a height of 3 centimeters. I will give you 1 minute to answer, and your timer starts now. Okay, time's up. What's your answer? Very good. It's 60 cubic centimeters. So we have here our length is 5, our width is 4, and our height is 3. So 5 times 4 is 20. Times 3 is 60. So we have here 60, and let's not forget our units. So 60 cubic centimeters. Do you have questions for finding the volume of a rectangular prism? Okay, since none, then let's proceed to finding the volume of a cube. Now, how many cubic units are there in this bigger cube? Yes? That's right, there are 27. How did you get 27? Yes, Sarah, you are raising your hand. So very good. So all we have to do is to simply multiply the edge length 3 times by itself. So 3 times 3 times 3 is equal to 27.
The volume of a cube. So the formula in finding the volume of a cube is very closely similar with that of the rectangular prism. So the volume of a cube is equal to edge times edge times edge, or e to the power of 3.
And now let's try to find the volume of a cube if its edge is 4 centimeters. I will give you 1 minute to answer, and your timer starts now. Okay, time's up. What's your answer? Yes, lovely. Very good. The answer is 64 cubic centimeters. So to answer the question, we have here our edge length is 4 centimeters. So we will raise it to the power of 3. So 4 times 4 is 16. Times 4 is 64. So let's not forget our unit, 64 cubic centimeters.
Relationship between the volume of rectangular prism and pyramid. The relationship between the volumes of pyramids and prisms is that when a prism and pyramid have the same base and height, the volume of the pyramid is 1/3 of the volume of the prism. Volume of a rectangular pyramid. The volume of a pyramid is one-third that of a prism with the same base and height. The base of a rectangular pyramid is rectangle, so to find its area, multiply the length and the width and the height. Then divide the result by 3.
Okay, so using the formula 1/3 times length times width times height, we get. So what's our length again? Very good, it's 10 inches. How about our width? Very good, it's 8. And how about our height? It's 14. So we have here. So 1/3 of 1,120 is, what's the answer? Very good. The answer is 373 and 33 cubic inches. So that's it.
Relationship between the volume of cylinder and cone. The volume of a cylinder, as related with that of a cone, is similar with that of a prism and pyramid. It means that the volume of a cone is one-third the volume of a cylinder if their bases and heights are equal. So volume of a cylinder, we have here the formula. Volume of a cylinder is equal to pi r squared times h. And for the volume of a cone, we have here the formula 1/3 pi r squared times height.
The radius of the circular base of a cylindrical container is 28 centimeters and its height is 30 centimeters. What is the volume of a cone with the same base and height as the container? So the formula in finding the volume of a cylinder is pi times r squared times height. And what is the value of our pi? Very good, it's 3.14. And we can also use 22 over 7. It still gives the value of 3.14. What about our radius? It's 28 centimeters, right? How about our height? What's our height again? Very good, it's 30 centimeters. Now let's compute. What is 22 over 7 times 28 squared times 30? Who got the answer? Yes, Christine, your answer is very good. It's 73,920 cubic centimeters. So let's write here 73,920 cubic centimeters. Okay, so to find the volume of a cone, we have the formula 1/3 times the volume of a cylinder. What's the formula for finding the volume of our cylinder again? Very good. It's pi times r squared times height. So in here we can write pi times r squared times height. And since we have here 1/3, right, so we'll write over 3. Now, what's the value of our what's the volume of our cylinder? We have here the answer. Yes, 73,920 cubic centimeters, and we will divide it by 3. So, what is 73,920 divided by 3? Okay, who has the answer? Yes, Brittany, your answer is very good. It's 24,640 cubic centimeters. So we write 24,640 cubic centimeters. And now, in your seats, kindly try to answer this problem. If the height of a given cone is 7 centimeters and the diameter of the circular base is 6 centimeters, then find its volume. I will give you 2 minutes to answer, and your timer starts now. Okay, time's up. Who has the answer? Yes, your answer is? Okay, your answer is 70 cubic centimeters. Who has other answers? Yes, Krista. Okay, your answer is 66 cubic centimeters. So let's try to solve the problem. We have here, right, the formula in finding a cone. 1/3 times pi r squared times height. So here 1/3. Our pi, we can write 22/7. What is our radius? It's 3. So, we will write 3 squared. And how about our height? It's very good. It's 7. So, what is 22/7 times 3 squared times 7? Very good. We have the answer, 198. And 1/3 of 198 is, it gives you the answer. Very good. The answer is 66 cubic centimeters.
Now, relationship between the volume of cylinder and sphere. The radius of the sphere is equal to the radius of the base of the cylinder, and the height of the cylinder is equal to twice the radius of the sphere. So we have here the formula of a cylinder. So area of the circular base times height. So pi r squared times h. And then for the volume of the sphere, we have here 2/3 pi r squared times h, or 2 pi r squared times height over 3.
Now, let's try to answer the problem. What is the volume of the cylinder whose base has a radius of 2.5 decimeter and whose height is 5 decimeter? So we have here the formula in finding the volume of a cylinder. So volume of a cylinder is equal to pi times r squared times height. So what's the value of our pi? Yes, we can write here 3.14. 22/7 is still fine. We can write here 3.14 times what is our radius? We have, very good, 2.5 decimeter. So since we have here squared, right? So we have to square our radius. And how about our height? It's 5 decimeters. Now, what is 3.14 times 2.5 squared times 5? Anyone who has the answer? Yes, Angel, your answer is very good. The answer is 98.125 cubic decimeter. And now let's have another problem. The radius of a sphere is 2.5 decimeter. What is its volume? So what's the formula again in finding the volume of a sphere? That's right, we have it here, 2/3 times pi r squared times height. So we can write here, so we have 2/3. So we will write it like this. Now, what is the volume of our pi? We have 3.14 times our radius is 2.5. So we have to square our 2.5, and then our height again is 5 decimeter. Okay, so what is 2 times 3.14 times the square of 2.5 times 5 divided by 3? Who has the answer? Yes, Joshua. So very good. We have the answer, 65.42 cubic decimeters. 0.42 cubic decimeters. Now, are there further questions regarding the finding the volume of a cylinder and a sphere? Okay, since there are none, then that would be all. Thank you.
Now, for the engaging activity, I will have the students play Volume Scoot. The Volume Scoot is a fun classroom learning activity, and to play the game, students travel from desk to desk around the classroom answering questions or solving math problems involving finding the volume of objects.
Okay, so how important is it to incorporate engaging activities in the classroom? Yes, Ms. Akabal, you are raising your hand. Very good. So let us just not forget that increased engagement can lead to increased learning gains, which can also be helpful in helping the learners have a greater retention of the learning material. So let's just not forget on that. Okay, so that ends our discussion.